Yes, pulling two 20-amp branch circuits from the main house panel to a detached pole barn is permissible. However, specific requirements must be met to ensure a safe and compliant installation. Firstly, using separate conduit is essential. Each branch circuit must have its own dedicated conduit running to the pole barn. This separation ensures proper circuit isolation and provides enhanced protection against potential faults. Secondly, conduit sizing needs consideration. The conduit selected must be adequately sized to accommodate the number and gauge of conductors being installed. Typically, a 1/2-inch conduit or larger is sufficient for 20-amp circuits, but always verify this based on the specific conductors chosen and relevant electrical codes. Thirdly, insulation of conductors is key. The conductors used must be properly insulated to withstand the voltage and temperature conditions present in the installation environment. Use conductors rated for the appropriate voltage, typically 600 volts, and temperature, such as 75 or 90 degrees Celsius, as specified by the equipment and local codes. Fourthly, grounding is paramount. Each branch circuit must include a dedicated ground wire that is correctly connected to the grounding system at both the house panel and the pole barn. This ground wire provides a low impedance path for fault currents, helping to protect against electrical shock and equipment damage. Fifthly, the total distance from the house panel to the pole barn is critical. Voltage drop, which is the reduction in voltage along the length of a conductor, can become a significant concern, particularly over long distances for 20-amp circuits. Calculate the voltage drop using appropriate formulas or online calculators, considering the conductor gauge, circuit current, and distance. If the voltage drop exceeds acceptable limits, you may need to increase the conductor size to minimize the voltage drop and ensure adequate voltage at the pole barn. Sixthly, circuit protection is mandatory. Each branch circuit must be protected by a 20-amp circuit breaker or fuse located within the house panel. These overcurrent protection devices are designed to interrupt the circuit in the event of an overload or short circuit, preventing damage to the wiring and connected equipment. Seventhly, separating the lighting and outlet circuits is good practice. By using separate branch circuits for lighting and outlets, you minimize the risk of overloading a single circuit. This separation ensures that if one circuit experiences a fault or overload, it will not affect the other circuit. Additional considerations should include an assessment of the environmental conditions in the area where the conduit will be installed. If the conduit will be exposed to outdoor elements or damp locations, use weatherproof conduit fittings and equipment designed for such environment. These fittings help prevent moisture from entering the conduit and causing corrosion or electrical faults. Obtaining necessary permits from your local building code authority is an important step before commencing the installation. Electrical work typically requires permits to ensure compliance with local codes and regulations. Contact your local building department to determine the permit requirements and schedule any necessary inspections. To elaborate further on the topic of conduit, it is important to select the correct type of conduit for the application. Common types of conduit include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, also known as EMT, rigid polyvinyl chloride conduit, also known as rigid polyvinyl chloride, and flexible metal conduit. Rigid metal conduit and intermediate metal conduit offer excellent physical protection and are suitable for locations where the conduit may be subject to impact or damage. EMT is a lighter weight option that is commonly used for indoor applications. Rigid polyvinyl chloride is corrosion resistant and is often used in underground or wet locations. Flexible metal conduit is used for short runs or where flexibility is required. When selecting conductors, consider the ampacity, which is the current carrying capacity of the conductor, and the insulation type. The ampacity of the conductor must be equal to or greater than the circuit breaker or fuse size. Common insulation types include THHN, THWN, and XHHW. THHN and THWN are commonly used for general-purpose wiring, while XHHW is suitable for wet locations. Grounding electrode conductors play a crucial role in safety by connecting the grounding system to a grounding electrode, such as a ground rod or water pipe. The size of the grounding electrode conductor is determined by the size of the service entrance conductors. Proper grounding ensures a low impedance path for fault currents, helping to protect against electrical shock and equipment damage. Ground fault circuit interrupters, known as GFCIs, are devices that detect small imbalances in current and quickly interrupt the circuit, protecting against electrical shock. GFCI protection is required in certain locations such as bathrooms, kitchens, and outdoor areas. When installing outlets, use tamper-resistant receptacles, particularly in areas where children may be present. Tamper-resistant receptacles have internal shutters that prevent foreign objects from being inserted into the slots, reducing the risk of electrical shock. Surge protection devices, known as SPD, protect sensitive electronic equipment from voltage spikes and surges. SPD can be installed at the main panel or at individual outlets. Consider the use of arc fault circuit interrupters, known as FSIs, which detect arc faults, which are dangerous electrical conditions that can lead to fires. FSIs are required in certain locations, such as bedrooms. Consider energy efficiency when selecting lighting fixtures and appliances. LED lighting is more energy efficient than traditional incandescent lighting and can save money on electricity bills. Energy Star rated appliances meet certain energy efficiency standards and can also save money on electricity bills. Proper labeling of circuits is important for safety and troubleshooting. Label each circuit breaker or fuse with a description of the circuits it protects. This makes it easier to identify and energize the correct circuit when performing maintenance or repairs. Electrical work should always be performed by a qualified and licensed electrician. If you are not comfortable performing electrical work yourself, it is best to hire a professional. Electricians have the training and experience to perform electrical work safely and in compliance with electrical codes. Consider future needs when designing the electrical system for the pole barn. Plan for additional circuits or outlets to accommodate future expansion or changes in equipment. It is always better to have more capacity than you currently need. Regularly inspect the electrical system for any signs of damage or wear. Look for cracked or frayed wires, loose connections, and damaged outlets or switches. Address any issues promptly to prevent electrical hazards. Keep electrical panels and equipment clean and free of obstructions. Dust and debris can accumulate and cause overheating or other problems. Proper maintenance can extend the life of electrical equipment and ensure safe operation. Always de-energize circuits before performing any electrical work. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Never work on live circuits. Electrical safety is paramount. Follow all safety precautions and electrical codes to prevent electrical shock, fire, and other hazards. If you are unsure about any aspect of electrical work, consult with a qualified electrician. Remember that electrical codes and regulations vary by location. It is important to comply with all applicable codes and regulations to ensure a safe and legal installation. Obtain the necessary permits and inspections to verify compliance. Stay informed about changes in electrical codes and technology. Attend training courses or workshops to keep your knowledge and skills up to date. Continuous learning is essential for maintaining electrical safety and competence. Consider the use of smart home technology in the pole barn. Smart outlets, switches, and lighting can be controlled remotely and can improve energy efficiency and convenience. Smart home technology can also enhance security and safety. When installing wiring underground, use direct burial cable or conduit approved for underground use. Direct burial cable is designed to withstand the harsh conditions of underground environments. Conduit provides additional protection for the wiring. Proper depth of burial is essential to prevent damage to the wiring. Consult local codes for minimum burial depth requirements. Consider the use of a generator for backup power in the event of a power outage. A generator can provide temporary power for essential lighting, appliances, and equipment. Ensure that the generator is properly sized for the load and is connected to the electrical system through a transfer switch. A transfer switch prevents backfeeding of power onto the utility grid, which can be dangerous for utility workers. Consider the use of a solar power system to generate electricity for the pole barn. Solar panels can be installed on the roof or ground mounted. Solar power can reduce reliance on the utility grid and can save money on electricity bills. Solar power systems may be eligible for tax credits or rebates. When installing electrical equipment in a pole barn, consider the specific requirements of the equipment. Some equipment may require dedicated circuits or specific voltage levels. Consult the manufacturer's instructions for proper installation and operation. Pay attention to wire management and organization. Use cable ties, straps, or other methods to keep wires neat and organized. This makes it easier to troubleshoot and maintain the electrical system. Avoid running wires across walkways or other areas where they could be damaged or create a tripping hazard. Use conduit or cable trays to protect wires in these areas. Consider the use of a lightning protection system for the pole barn. A lightning protection system can protect the structure and its contents from damage caused by lightning strikes. Lightning protection systems typically include lightning rods, conductors, and grounding electrodes. Regularly inspect the lightning protection system for any damage or corrosion. Consider the use of a security system for the pole barn. A security system can deter theft and vandalism. Security systems typically include sensors, alarms, and cameras. Monitor the security system remotely through a smartphone or computer. Consider the use of a fire alarm system for the pole barn. A fire alarm system can detect fires early and provide warning to occupants. Fire alarm systems typically include smoke detectors, heat detectors, and audible alarms. Connect the fire alarm system to a central monitoring station for emergency response. Consider the use of a carbon monoxide detector for the pole barn. Carbon monoxide is a colorless, odorless gas that can be deadly. Carbon monoxide detectors can detect the presence of carbon monoxide and provide warning to occupants. Install carbon monoxide detectors near sleeping areas. Test carbon monoxide detectors regularly to ensure they are working properly. Consider the use of a whole house surge protector. A whole house surge protector can protect all of the electrical equipment in the pole barn from voltage surges. Whole house surge protectors are installed at the main electrical panel. Consider the use of a power conditioner. A power conditioner can improve the quality of the power supply to sensitive electronic equipment. Power conditioners can filter out noise and voltage fluctuations. Consider the use of an uninterruptible power supply, also known as a UPS. A UPS can provide backup power for a short period of time in the event of a power outage. UPS units are commonly used to protect computers and other critical equipment. When selecting electrical equipment, choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories, known as UL, or Intertek, also known as ETL. Listing by a testing laboratory indicates that the equipment has been tested and meets safety standards. Read and follow all instructions provided by the manufacturer of electrical equipment. Proper installation and operation are essential for safety and performance. Keep a record of all electrical work performed in the pole barn. This record should include a description of the work, the date it was performed, and the name of the electrician. This record can be helpful for troubleshooting and future maintenance. Consider the use of a ground fault circuit interrupter, known as GFCI, extension cord when using power tools or other electrical equipment outdoors. A GFCI extension cord can protect against electrical shock in wet or damp conditions. Inspect extension cords regularly for damage or wear. Replace damaged extension cords immediately. Avoid overloading extension cords. Overloading extension cords can cause overheating and fire. Consider the use of a power strip with a surge protector. A power strip with a surge protector can protect electronic equipment from voltage surges. Avoid plugging multiple power strips into each other. This can overload the circuit. Consider the use of a timer for lighting or other electrical equipment. A timer can automatically turn the equipment on and off at preset times. Timers can save energy and improve convenience. Consider the use of a remote control for lighting or other electrical equipment. A remote control can allow you to turn the equipment on and off from a distance. Remote controls can be useful for controlling lighting in hard-to-reach areas. Consider the use of a motion sensor for lighting. A motion sensor can automatically turn on the lighting when motion is detected. Motion sensors can save energy and improve security. When working with electrical equipment, wear appropriate personal protective equipment. This may include safety glasses, gloves, and insulated shoes. Avoid working with electrical equipment in wet or damp conditions. Water can conduct electricity and increase the risk of electrical shock. If you must work with electrical equipment in wet or damp conditions, use extreme caution and take all necessary safety precautions. Never allow children to play near electrical equipment. Electrical equipment can be dangerous and can cause serious injury or death. Keep electrical equipment locked or secured to prevent unauthorized access. Prevent animals from accessing electrical equipment. Animals can damage electrical equipment and create safety hazards. Inspect the electrical system regularly for signs of pests or rodents. Take steps to eliminate pests or rodents and prevent them from returning. Consider the use of a pest control service. If you have any questions or concerns about electrical safety, consult with a qualified electrician or electrical inspector. They can provide expert advice and guidance. Remember that electrical safety is everyone's responsibility. By following these safety precautions, you can help to prevent electrical accidents and ensure a safe environment.